All right, reviewing on the test. So for the first problem, we know we got 2 grams copper sulfide. We're looking for grams of nitric acid. So 2.00 grams copper sulfide. Get rid of our grams of copper sulfide. Go to moles of copper sulfide. 1 mole is 95.5 grams by using the molecular mass, using the periodic table. Get rid of our moles of copper sulfide, go to moles of HNO3. Our mole ratio is 8 to 3. Again, that's just the numbers right here from the equation. And lastly, we need to get rid of moles of HNO3, grams HNO3. 1 is 63. 1 mole is 63 grams. And so we can see the grams cancel out, moles cancel out, moles, and we're left with, if we do the math, 3.5 grams of HNO3. On this one, we know that we have 3. This one. We know we've got 3.5 grams of fluorine, and we're looking for the sulfur hexafluoride. So we've got 3.5 grams of fluorine. Get rid of our grams of fluorine, go to moles. Fluorine, 1 mole is 38 grams because it is diatomic. Each one is 19. 19 times 2 is 38. Now I get rid of our moles of fluorine, go to moles of sulfur hexafluoride. We're looking for, again, from the equation, that's a 3 to 1. There's our 3. There's our 1. Last thing we need to do is get rid of our moles of sulfur hexafluoride and go to grams. 1 mole is 146 grams. 6 times 19 plus 32. 4.5 grams sulfur hexafluoride. Next one, we got to figure out an excess of limiting. So I've got 15 grams of copper chloride. Get rid of my grams of copper chloride, moles of copper chloride. 1 mole is 134.5 grams if I add them all up. That means I have available 0.112 moles of copper chloride. And if I want to figure out how many moles of sodium nitrate that I'm going to need, I'm going to get rid of my moles of copper chloride, go to moles of sodium nitrate. And according to our ratio, I need a 2 to 1. So that means that I would need, let's see, I would need to have 0.224 moles of sodium nitrate. Let me erase that. Na, that's not getting any better. So I would need 0.224 moles NaNO3. Now, I have 20 grams of sodium nitrate, which if I get rid of some grams of sodium nitrate, moles of NaNO3, 1 mole is 85. So 20 divided by 85 is 0.235 moles of sodium nitrate. All right, so I can see that if I need this much, and I have this much, I have too much sodium nitrate. In fact, I have 0.11 moles of sodium nitrate too much. And if I take that times 85, that means I have about 0.96 grams of sodium nitrate too much, which is what we're looking for. All I did was multiply by the molecular mass, and that gives me my answer. On the fourth one, now I've got 5 grams of aluminum and 5 grams of sulfur. Sulfur is 32 grams in 1 mole of sulfur. Aluminum is 27 grams in 1 mole of aluminum. And if I then say, okay, I need to get rid of my moles of aluminum and go to moles of sulfur, it's a 3:2 ratio, which means I would need 0.0277 moles of sulfur. Well, if I multiply this out, I only have 1.156 moles of sulfur. So again, this is what I have. This is what I need. I don't have enough. So that's limiting. So I can start with my 156 moles of sulfur. That's going to determine my amount of product. Get rid of my moles of sulfur, go to moles of aluminum sulfide, which is a 1:3 ratio. Get rid of my moles of aluminum sulfide, go to grams of aluminum sulfide. It's 150 grams in a mole, so I should make 7.8 grams of Al2S3. Again, I had to figure out my have and my need. I picked sulfur and I happened to pick the right one. So I have 0.156, and that determines my product that I can make right there. The last problem, we had to figure out a percent yield. We start with 5 grams of Ki that says it's a limiting. Get rid of my grams of Ki, go to moles of Ki. 1 mole of that is 166 grams. Then I get rid of my moles of Ki, go to my moles of PbI2, take 1:2 ratio. And lastly, get rid of my moles of PbI2, go to grams, PbI2. 1 mole is 461 grams. Everything cancels out again, so I should make 6.9 grams of PbI2. According to the problem, I did make 3.65. That's my experimental, divided by my theoretical, would give me about a 53% yield. Again, percent yield is experimental over theoretical.